Cargo container mushroom farms are everywhere in the specialty mushroom industry right now. Social media is full of walkthroughs, time lapses, and harvest videos showing containers producing hundreds of pounds of fresh mushrooms per week. What almost none of that content provides is the one number every serious grower actually needs. What does it cost to build one? Not a vague range, not an aspirational estimate designed to sell a course. The actual dollar amount from empty steel box to producing operation with every component, every system, and every line item on screen. The total lands in a range that this video will itemize completely. The build cost is significant. The payback timeline is shorter than most people expect once the production math is laid out beside it. This video covers the full build, the full production capacity, and the exact month the investment pays for itself. Every dollar accounted for. A standard 40-foot high-cube shipping container is a 320-square-foot steel box that solves every environmental control problem a mushroom grower faces in a single structure. The walls are air-tight. The interior is completely light-proof. Steel construction is inherently weather-resistant, pest-proof, and structurally sound without additional building materials. Once insulated and sealed, that steel shell becomes a controlled environment chamber where humidity, temperature, carbon dioxide levels, and airflow are managed with a precision that spare rooms, garages, and basement setups cannot match, regardless of how much equipment is added to them. Modularity is the advantage most growers underestimate until they need it. A container operation scales by adding containers, not by renovating buildings. Each container functions as an independent production unit. A second container doubles capacity without modifying the first. A third triples it. The expansion math is linear and predictable in a way that building construction never is. Portability adds another layer. Containers relocate on a flatbed truck. If the business changes location or the grower sells the operation, the entire production facility moves with it. Unlike a building renovation, the investment is not permanently fixed to one piece of land. In many jurisdictions, shipping containers classify as temporary or agricultural structures rather than permanent commercial buildings. That classification simplifies permitting significantly and in some areas eliminates the requirement for a full building permit entirely. A spare room or a Martha tent can start a mushroom operation. A container professionalizes it into a controlled, scalable, year-round production facility that buyers, inspectors, and wholesale accounts take seriously. A climate-controlled container produces mushrooms 12 months a year in any climate zone on Earth. That year-round consistency is what transforms a seasonal side operation into a reliable business with standing orders, weekly market presence, and predictable cash flow. Oyster mushrooms are the primary revenue species for most container farms. Blue, pink, golden, pearl, and king oyster varieties all fruit reliably in container conditions and sell for $8 to $14 per pound at retail and $6 to $10 per pound wholesale. Fast colonization, predictable fruiting, and broad market demand make oysters the foundation species for any container build. Lion's mane commands a higher price point at $12 to $20 per pound and thrives in the stable conditions a sealed container provides. The species is sensitive to carbon dioxide fluctuations that plague open room grow setups. Container heating, ventilation, and air conditioning, and automated fresh air exchange handle that variable precisely. Shiitake carries premium pricing and excellent shelf life. The longer colonization period of 2 to 3 months on supplemented sawdust blocks suits a container operation well, because the consistent temperature control enables reliable cold shocking to trigger fruiting on a predictable schedule. Multi-species production in a single container is achievable with zoned shelving and targeted airflow management. Most Martha tent and spare room operations struggle with summer heat and winter cold, losing weeks or months of production to seasonal temperature swings. A container eliminates those variables completely. Year-round production means year-round revenue. Restaurant standing orders depend on consistent weekly supply. Farmers market customers return when the product is there every week without gaps. That consistency is what a container buys, and no amount of equipment in an uncontrolled space can replicate it. A used 40-foot high-cube shipping container in good condition costs between $2,500 and $5,000, depending on location, condition, and regional availability. One-trip containers, near-new units that have made a single ocean crossing, run $4,000 to $7,000. For a mushroom farm where the interior will be fully insulated and modified, a used container in structurally sound condition with no significant rust or floor damage is the cost-effective choice. Delivery to the site runs $300 to $1,500, depending on distance from the nearest port or container depot. The container arrives on a flatbed truck and requires either a tilt bed unload or a crane, depending on site access. The site itself needs a level surface. A gravel pad or concrete footers are the two standard options. Cost ranges from $500 to $2,000, depending on terrain, drainage requirements, and whether the grower does the prep or hires it out. Insulation is the most critical structural investment. Closed-cell spray foam is the industry standard for mushroom containers because it seals against moisture infiltration while providing high R value per inch. 2 to 3 inches on the walls, ceiling, and floor costs $2,000 to $4,000 for a 40-foot container. Skimping on insulation is the single most common build mistake, and it creates condensation problems that destroy mushroom quality and invite contamination throughout the life of the operation. Interior framing. Using metal stud or wood creates the structure for shelving attachment and zone separation between incubation and fruiting areas. Cost runs $500 to $1,500, including materials and labor. Flooring must be sealed for washdown sanitation. Epoxy coating or fiberglass reinforced panels are the standard choices at $500 to $1,500. Door modifications, retaining the cargo doors and adding a personnel entry or sealed pass-through for loading blocks, add $200 to $800. Structural subtotal for the complete shell is $6,500 to $22,300. The container is just a box. The environmental control systems inside it are what make it a mushroom farm. Temperature control comes first. A mini-split HVAC system maintains precise temperatures between 55 and 75 degrees Fahrenheit year-round, regardless of outdoor conditions. Installed cost runs $1,500 to $3,500 depending on unit capacity and whether the grower handles mounting or hires an HVAC technician. Humidification is the second most critical system. Mushrooms fruit at 85 to 95% humidity. A commercial-grade ultrasonic humidifier or misting system capable of sustaining that level in a 320 square foot sealed space costs $500 to $2,000. Undersized humidifiers that cannot maintain target humidity during high production periods are the second most common build mistake after insufficient insulation. Fresh air exchange controls carbon dioxide levels inside the container. Elevated carbon dioxide causes elongated stems, small caps, and deformed fruit that will not sell. Inline fans with ducting, filtered intake, and automated dampers cost $500 to $1,500. An environmental controller that automates humidity, temperature, fresh air exchange, and lighting from a single unit runs $500 to $2,000 for commercial mushroom-specific systems. Do it yourself. Builds using Arduino boards and sensors can achieve comparable automation for $150 to $400 with significantly more setup time. Shelving runs the length of the container on both sides, 4 to 5 tiers high. Heavy-duty stainless steel or powder-coated wire shelving costs $500 to $1,500. LED strip lighting for pinning triggers adds $50 to $200. Electrical wiring including a dedicated circuit panel, GFCI outlets rated for wet environments, and connections for all systems costs $1,000 to $3,000 installed by a licensed electrician. Water supply and floor drain plumbing for sanitation washdowns adds $500 to $1,500. Environmental systems subtotal, $5,250 to $15,700. Combined with the structural build, the total container mushroom farm cost is approximately $11,750 to $38,000. A properly shelved 40-foot container holds 400 to 600 fruiting blocks at a time, depending on block size and shelf spacing. Each block cycle, from inoculation through final flush, runs approximately 6 to 8 weeks for oyster mushrooms. Staggered inoculation means new blocks enter the container weekly as finished blocks are removed, creating continuous rolling production without downtime. Each 5-pound substrate block produces 1 to 2 pounds of fresh mushrooms across 2 to 3 flushes. With 400 to 600 blocks in continuous rotation, monthly production at steady state lands between 800 and 2,400 pounds of fresh specialty mushrooms. Annual output from a single 40-foot container is 10,000 to 28,000 pounds. That range depends on species mix, block cycling efficiency, and how tightly the production schedule is managed. Compare that to a Martha tent operation producing 40 to 100 pounds per month. A single container produces 8 to 25 times that volume from a 320 square foot footprint. The production density per square foot is unmatched by any other small farm structure at this price point. Year-round environmental control eliminates the seasonal production gaps that cripple uncontrolled growing setups. No summer heat stalling colonization, no winter cold slowing fruiting, no weeks of lost production waiting for outdoor temperatures to return to a manageable range. Output is consistent month after month, which is precisely what restaurant accounts and weekly market customers require from a supplier they are willing to commit standing orders to. At wholesale pricing alone, $6 to $12 per pound, a container producing 1,000 pounds per month generates $6,000 to $12,000 in monthly revenue. At retail through farmers markets and online sales, $8 to $16 per pound, that same volume reaches $8,000 to $16,000. Most container operations sell through a blend of channels. Realistic blended monthly revenue for a single container at steady production, $8,000 to $14,000. Annual gross revenue from one 40-foot container, $96,000 to $168,000. That figure gets the attention it deserves only when operating costs are subtracted honestly. Spawn at production volume runs $1,500 to $3,000 per month. Substrate materials add $500 to $1,000. Electricity for HVAC, humidification, fans, and lighting costs $200 to $500 monthly depending on climate zone and local rates. Packaging and supplies add another $200 to $400. Labor at owner-operator scale or with one part-time employee is variable but real. Monthly operating cost estimate, $3,000 to $6,000. Monthly net revenue before the owner's labor, $2,000 to $10,000 depending on production volume, channel mix, and operating efficiency. Against a build investment at the midpoint of roughly $20,000, break-even arrives in 3 to 12 months. At $6,000 monthly net, the container pays for itself in under 4 months. At the conservative end, the timeline stretches but remains well within the first year of production. No other agricultural structure at this price point approaches that payback speed from 320 square feet. The build cost is real. It is not the only number that determines whether the project moves forward or stalls. Several factors outside the container itself add cost, delay timelines, or create problems that most container farming content never mentions. Zoning is the first variable to verify before purchasing anything. Shipping containers are classified differently across jurisdictions. Some municipalities allow them as agricultural or temporary structures with minimal permitting. Others require full commercial building permits, site plans, and inspections that add thousands of dollars and months to the timeline. Verify classification with the local planning office before committing $1 to the project. Electrical infrastructure is the second cost most builds underestimate. A container mushroom farm draws significant power. HVAC, humidification, fans, lighting, and automation require a dedicated electrical panel. If the container site is more than 50 feet from existing infrastructure, running power can add $1,000 to $5,000 or more depending on distance and local electrician rates. Water supply and drainage follow the same pattern. Humidification systems and sanitation washdowns require running water. If no water access exists at the container location, installation can add $500 to $3,000. Floor drainage for washdowns is frequently overlooked during build planning, and retrofitting it after the container is operational is significantly more expensive than including it from the start. Common build mistakes cost more than contingency budgets. Insufficient insulation creates condensation that destroys mushroom quality permanently. Undersized HVAC cannot maintain fruiting temperatures during summer heat spikes. Poor fresh air exchange design creates carbon dioxide pockets that cause deformed fruit across entire shelving sections. Mixing incubation and fruiting zones in a single undivided space without airflow separation reduces production efficiency by 20 to 30%. Add 15 to 20% to the total build estimate as a contingency budget. Unexpected costs appear on every container build without exception. The full build does not have to happen in a single investment. Start with a Martha tent operation at $300 to $500. Generate revenue, build buyer relationships, and learn the production cycle. Revenue from that phase can fund the container purchase and delivery. Begin structural modification with insulation and framing as cash flow allows. Install environmental systems one at a time. HVAC first, then humidification, then automation, each addition increasing production capacity and consistency. Most successful container farms followed exactly this progression. The container is not a sunk cost. It is a portable, resaleable business asset that moves with the operation if the location changes. A cargo container mushroom farm is not a building project. It is a revenue machine with a known build cost and a break-even timeline measured in months. Subscribe for more commercial mushroom farming strategies. Drop a comment and tell us whether you are in the Martha tent phase or ready for the container build.